we'll look at some of the homework problems in section 6.3 that deals with multiplication and division of fractions. In this case, problem A, well, the first problem is to find each of the following products, and then you're going to write the answers in simplest form. So in part A, we have 32 over 85 times 34 over 96. I'll write this on the side so pretty much y'all can see this. 32 85ths times 34 96. There is some cases that you can do some cross dividing. In other words, you can find some number that can go into these two numbers going this way, and numbers that are divisible by these two, a number that's divisible by these two numbers going this way. Let's start with the 32 and the 96. 32 is the biggest number that can go into 32 and 96. Well, 32 goes into itself one time, 32 goes into 96 three times. Now for the 34 and the 85, I know 17 is the biggest number that can go into 34 and 85. So here, 17 goes into 34 two times, 17 goes into 85 five times. Now we multiply numerator times numerator and denominator times denominator. 1 times 2 is 2, divided by 5 times 3, which is 15. Okay, so here 32 85ths times 34 96 will give you 2 15ths as the final answer. Okay, part B is one with variables in it, y divided by v times, well, y over v times v squared over y squared. Now again, you can do some dividing, cross dividing. I know y goes into itself one time, y goes into y squared y times. Because I can break y squared up into y times y, and one of the y's will divide out. In the same notion here, v squared divided by v goes into itself one times, v goes into v squared v times. Because I can break v squared into v times v, and one of the v's will divide out. In the numerator, I'm going to be left with a v. The denominator, I'm going to be left with a y. So this will be, as the final answer, v over y. And then part C, you got TQ over C times C squared P over T cubed Q squared. Okay. TQ over C times C squared P over T cubed Q squared. Okay, let's do some cross dividing. One of the t's can be crossed out. This t can be gone. One of the t's in t cubed will be crossed out. I'm left with t squared. For the c, one of the c's can be crossed out. This c can be gone. This c up here can be gone in c squared. I'm left with the c. Now for the q, this q, one of the q's in q squared is gone. I'm left with just the one q. Now, in the numerator, I'm just going to be left with a c and a p. The denominator, I'm left with t squared and a q. So, tq over c times c squared p over t cubed t squared will be, in simplest form, cp over t squared q. Okay. All right, problem number 2. We're going to find what they call the multiplicative inverse, which is another word for the reciprocal. So actually, we're finding the reciprocal of 8 1/7. First of all, we need to convert 8 1/7 to an improper fraction, and then convert that improper fraction into its reciprocal. Find its reciprocal. So for 8 1/7, if we want to convert that to an improper fraction, we multiply 7 times 8, which is 56, plus the 1, that's going to be 57. over 7. Okay? Because we multiply the denominator times the whole number and then add the numerator to get our numerator over that denominator, which is 7. Now, the reciprocal of 57 over 7, we just flip this over, invert. So it'll be 7 over 57. So the multiplicative inverse, or the reciprocal of 8 and 1/7, would be 7 over 57. Okay. Take a look at problem number 3. Solve using the multiplication principle. In this case, you got 2/7 s divided equals to negative 8 over 9. And I'm going to write this on a separate sheet of paper so you can see how I'm going to do this. 2/7 s is equal to negative 8 over 9. In this case here, we want to solve for s. We're multiplying by 2/7. Now, normally we would divide both sides of this equation by 2/7. However, since we're dealing with fractions here, it would be much easier to multiply by the reciprocal of 2/7, which is in this case 7 over 2. So I'm going to multiply this side, the left side, and the right side by 7 over 2. Now what's going to happen is these 7s and these 2s are going to divide out. I'm left with s. The right side I have 7/2 times negative 8 over 9. Well, I know I got a negative sign, so we'll just bring that down. Now, I can divide 2 into 8. 2 goes into itself 1 time, 2 goes into 8 4 times. So now you got 7 times 4, which is 28. And then the denominator, 1 times 9, would be 9. So the value of s will be negative 28/9 as our answer. Okay. All right, problem number 4. You want to perform the proper calculations and reduce your answer whenever possible. Here we got a multiplication problem of 12 times 1 and 5/6. 12 times 1 and 5/6. In this case here, I'm going to go ahead and write the 12 as 12 over 1 times the 1 and 5/6. I need to convert that to an improper fraction. Multiply 6 times 1, that will be 7, plus the 5 would be 12. No, I'm sorry, it's 11. 1 times 6 times 1 is 5, plus 6 times 1 is 6, plus 5 is 11 over 6. So now I got 12 over 1 times 11 over 6. Okay, now I can do some cross dividing here with the 12 and the 6. Here, 6 goes into itself 1 time, 6 goes into 12 2 times. 2 times 11 will be 22 over 1. The final answer there will be 22. Okay, problem number 5. A local government had an employee reduction and lost 1/8 of its employees. If 154 of its employees were left after the reduction, how many employees were there originally? Okay, now this, we're going to have to set this up as an equation. So let's look at this here. I'm going to let x be the original number of employees. Okay. Now, we lost 1/8 of its employees. So, the original employee says x, and then we lost 1/8, so that's minus 1/8 of the original number, 1/8 times x. And we ended up with 154 employees after the reduction. So here we have an equation, x minus 1/8 x equals 154. Okay, now we need to simplify this. You're going to have to think of x as 1x. Now we subtract 1 whole from 1/8. There are 8/8 in a whole, so 8/8 minus 1/8 is 7/8. So here that's 7/8 x equals 154. Okay. Now you have to think of 1 whole again. Split this up in eighths. How many pieces do you have? There are 8 of them. So that's why 1 whole is 8/8. And then I subtracted the 8/8 minus 1/8 to get that 7/8. Okay, now to get x by itself, you need to, well, the easy way to do this, take the reciprocal of 7/8, which is 8/7. So here we're going to multiply both sides by that reciprocal, which is 8/7. So here I'm just going to have x by itself because the 8s and the 7s will divide out. Let's see, 8/7 times 154 over 1. I think we can do some cross dividing here because I think 7 goes into 154 22 times. So I'm going to put a 1 here and then 22 here, and then 22 times 8 will be 176. Okay, so before the reduction, there were 176 employees, which is what we were trying to find, the original number of employees. Okay, problem number 6. Al saved pennies. He agreed to give 6/13 of his pennies to Bev if she would give 6/13 of what she got from Al to Carl. And if Carl, in turn, would give 6/13 of what he got from Bev to Danny. Bev, Carl, and Danny agreed, and Danny received 2,592 pennies. How many pennies did Al have initially? Okay, if you remember one of your problem-solving strategies, we're going to have to work backwards. Okay, so with this problem, we're going to have to work backwards here. We know the fact that Danny received 2,592 pennies, which was 6/13 of what she got from Bev. So we know here, I'm going to set this up as an equation. 6/13 x is equal to 2592. Okay, because that's the amount that Danny received from Bev. So now we need to multiply by the reciprocal, which is 13/6, on both sides. So x is equal to, and I could do 2592 times 13 divided by 6. Okay. So these are the number of pennies that Bev received. 5,600 has 5,616. Now these are the number of pennies that Carl received. I'm sorry. Carl received these pennies from Bev, and he's giving 6/13 of that to Danny. Okay, now let's work backwards. Bev is going to give 6/13 of what she got from Al to Carl. So if Carl has 5,616, we need to find out how many Bev had. So here, 6/13 times the amount that what Bev has is going to be the number of pennies that Carl has, 5,615. So this is for Bev. And then we multiply by 13 over 6 again on both sides. So that means that x is equal to, let's see, 5616 times 13 divided by 6. That's going to be 12,168. So Carl received Bev received 12,168 of those pennies. Okay, now finally we want to find out how many does Al has. Because he gave 6/13 of his pennies to Bev. And Bev has 12,168. So let's say 6/13 x is equal to 12,168. And then we're going to multiply by the reciprocal again, which is 13 over 6. So here x is equal to, 12,168 times 13 divided by 6, which will give you 26,364 pennies. So Al initially had 26,364 pennies. Okay. So to see how I did this, we started off with Danny having 2,592 pennies. Carl gave 6/13 of what he got from Bev to Danny. So 6/13 times x, that's 2,592. So you multiply by the reciprocal of 6/13, which is 13 over 6 on both sides, you'll get 5,616. That's the number of pennies that Carl received. But then we're told that Bev gave 6/13 of what she got from Al to Carl. So let's find out how many pennies that Bev has. 6/13 x equals to 5616, which is the number of pennies that Carl received from Bev. Multiply both sides by 13 over 6, which is the reciprocal of 6/13 again, you'll get the number of pennies that Bev had, which was 12,168. And then Al gave 6/13 of his pennies to Bev. So 6/13 of the number of pennies that he gave to Bev, well, the number of pennies he gave to Bev was 12,168. So we want to find out how many pennies he had originally. 6/13 times x equals this, 12,168. Multiply both sides by 13 over 6, you'll get the final number, which is 26,364 pennies that Al initially had. Okay. So this is one of those examples of working backwards in this particular problem. Problem number 7. Multiply and simplify. We got 8 to the second times 8 to the fourth. Here we're multiplying powers of the same base, so we just simply bring over the base, which is 8, and then add the exponents for your 8. 2 plus 4, which is 6. So 8 squared times 8 to the fourth would be 8 to the sixth. And finally, number 8. 2 to the x equals to 4. Which means we're trying to find 2 to what power gives us the answer of 4. Now, you'll have to think of, 4, and the base is 2. Divide 2 into 4, it's going to go 2 times. Count up how many 2's do you have. 2 is going to be used as a factor twice. So the missing exponent that we're looking for was 2. Okay, so that means that 2 to the second would give us 4. So the solution there will be x is equal to 2. Okay. And that should assist you with some of the homework problems in section 6.3.